Hey, we're back. It's episode 13. Today, making stuff. An elegant title for an elegant process. Okay, let's get going. Just for the people in here, in case you're wondering about the quality of the printouts, somebody used up the toner cartridge upstairs, so I had to print everything on my inkjet, and then so you know where that went, right? Okay, in any event, what's going on is the first thing, of course, immediately after I told you all the UPS manager was coming, I learned that visit is on hold, but so stay tuned, reschedule. You're a grad student and you think you're graduating, you better have turned in your application to graduate with the registrar. It's due tomorrow. That's 3 March. And if anyone says, oh, no one told me, I'm afraid the only thing you're going to hear from me is not positive. Because I'm going to tell you is you weren't reading your nmsu.edu email, which I remind people is the official communication tool. So keep that in mind. I put out assignment 3, and it's due next Wednesday at 11:59, and we'll get exam scheduled soon. We'll talk about it on Tuesday. We'll figure out what to do about all you characters that are asking, when is the exam? I said, why? Will it be a positive experience? No, all you're going to do is complain, right? Might as well let you worry some more. Okay, so in any event, we'll schedule that soon, and we'll see what happens with that. So, let's see, we're almost at spring break too, right? Yes, that sounds great, doesn't it? That's right. And take the faculty with you is my motto. Let's see. Well, certainly it has been an interesting semester with more to follow. Okay, so today, doing stuff. Our episode today is sort of philosophic, and it has some details. If you're going to do something, you need stuff. And then that means you have stuff around, and you have people, and so forth, right? Even if you are a one-person troubadour performing in coffee houses, you still have stuff you bring with you. So, yes, as we know from other classes, I tend to like to use garage bands as examples, but fundamentally you need a place to do it, people, a plan, parts, raw materials, and all that good stuff, and that's what we're going to talk about today. Historically, there are 3 ways people get organized. One is what's called a craft shop. Now, the craft model goes back to medieval times for real. That was the idea of the person who did the task did everything. And you'd have an apprentice, and then you would become a journeyman, and then a master of the craft, right? Kind of like writing a PhD, sort of. Well, that's the model they use anyway. The production line, of course, came along as things got more specialized and then the job shop, which you would recognize if you pictured for example, a giant Home Depot. Like the plumbing supplies are one place, the electrical another, right? Same idea with the machines and stuff. So there's three basic ways you can organize, right? And you could, for example, happily run your life as a craft shop. For example, you get off the treadmill to corporate America or the treadmill in the Army or Air Force, and you decide to move into the hills where you will make things with your hands of some type, right? So you're out there with your toolkit and you're building boats, for example. You're there, you go chop down your own trees, mill your own lumber, right? Already this is sounding unattractive, isn't it? Much better to go to Home Depot and buy lumber, right? Or a lumber yard or something. Right, that's why craft shops evolved. Now, actually, if you want to see some really cool craft work, I mean, in all seriousness, but super high-tech stuff, a lot of energy involved. The Corning Museum of Glass in upstate New York, with the surprise, their website is cmog.org, I think. Corning Museum of Glass has excellent videos of people doing glass work. Now that is something that's a skill. You watch people do this artistic glass stuff. I mean, the thing's burnt. They're sticking it in an oven at like 2,500 degrees, right? So that's serious high tech. And somehow they've got a camera in there, which I'm really intrigued by. I haven't found the video yet that explains how they're taking an end-on picture of the glass in the oven. But that is cool manufacturing work. So they have videos all over the place on YouTube that are great. And you can really see some people who really have spent their lives developing that skill. It's just great to watch. I mean, because I have it on Facebook, so once in a while they'll announce they're doing a video, and then they have the video there, and I'm sitting there watching people do this routine with the glass, and I said, wow, it's got to be something. And they actually have a setup where they'll mic the person and they have an audience and things like that. And then, like I say, they got a camera in the oven, which I'd like to figure out how they're doing that, find out, right? Okay, any event, there's lots of, thanks to the internet, you guys have unlimited examples to look at. You want to see something get built? Go stick it up on YouTube. Like, you know, it's not like you have to go to the plant to see it. So, any event, an excellent adventure. The question for today is, how does anything happen? And of course, everything can be different, but there's lots of parallels. Fundamentally, if I design something, will anyone buy it? Is a useful question, right? What happens? So ideally, along with your design, you have some market information that says somebody would actually buy your thing, whatever it is, whether it's a service or a thing, our friend with the polo shirts, for example, right? Whatever the particular thing is. Earlier this semester, we probably mentioned Under Armour, and let's see, Mr. Planck's been the source of some adventure after some of his political pronouncements, but Under Armour, what made that work was, at the original level, was that the stuff dried faster, which is a big deal when you're washing 150 T-shirts a day and all that sort of thing. You know, you're washing all those jerseys and things. It's a big deal. And then it's more comfortable. And if you're built right, it looks cool. Correct? If you really do look like an NFL D-back, it looks great. On the other hand, on some of those offensive linemen, it's a little less the compression garment, right? Any event, moving along, I run into a lot of people wearing Under Armour at the gym. This is always interesting. And so I personally don't wear it as a T-shirt, so. Okay, any event, there are parallels. And to make this easy for the vast array of undergrads who are in this class, these are the classes where you get stuff. We learn about plans, schedules, and orders in this class, the raw materials and how we make things, Chem ie361, ie217, me222, et217, right? The idea of a router will become important. That's a document that describes the steps to make something. Okay? The reason it's called a router is usually the thing is moving from step to step. So the route through the shop. Attached to the router is some time standards, which is ie316. The time standards help us develop how much capacity we need. Which you would get in 316 in this class. Because what we're interested in is what we're going to do, how we're going to do it, what do we need to do it, who do we need to do it, right? Kind of like this morning's adventure. This morning when I went to print the slides, the copier reported the toner cartridge was dead. Out of stock at the moment. Therefore, no copies, right? Therefore, and so on. Okay, so in any event, what we want to do is know what we're going to make. Yeah, you can see it on the little ones. Yeah, it's a little fuzzy, I know. That's because we've switched to these low-grade inkjet cartridges. The aftermarket ones, they're just not as good. Plus, my inkjet printer's like 15 years old. Somebody laughed when they saw it. I said, it still works. I mean, if I need a high-quality printer, usually I shoot it to the copier, right? We have the network copier. Okay, any event. Scheduling things. When do I make it? good idea not to cut down Christmas trees in April, right? Same idea here. Orders are what authorizes us to do things. A good metaphor might be, this weekend you suddenly decide to make chocolate chip cookies. Okay? Your version of a shop order is, hey, I think I'll make cookies. All right? In an actual facility, somebody has to say, go make cookies. Right? So you say you're going to go make cookies, right? So what do you need? You need oven, pan, ingredients, some of your labor, right? And what will you do? You take your list of materials and compare it with what's in the refrigerator and the pantry, right? And if you need things, suddenly the desire to make cookies is overcome by the need to go get stuff. Or not, right? But if you're making cookies for real, you can't, you can't say, we're not going to make cookies today because we don't have ingredients. Instead, we find out why we don't. The materials were already set, right? You have a list of materials. Could you experiment with that? Sure. Should you? Maybe not today, right? Unless you say, hey, the recipe calls for nuts and I don't have any, so we're going to just make them without the nuts or something. But then you have a quality problem, right? It's not the cookie that you usually make, is it? The configuration is wrong. The router would be the set of steps involved in making the cookies, right? You gotta get the ingredients. Butter has to come to room temperature, maybe, or what does that do? It backs off the time you have from start to finish, right? So, of course, what does the usual engineering student do? Hey, I could microwave that butter. And what happens? The butter melts unevenly, and you get a less good product, right? And so forth. So there are parallels to this. The time standards, if you're the first time you bake stuff on your own, takes a lot longer than once you've done it a few times, right? You move down, as we say, the learning curve from repetition, plus experience, right? And capacity is like that problem 43, right? The oven only handled 100 at a time, whether you liked it or not. Even if you calculated an EOQ of whatever, the oven only bakes 100. Okay, so that's fundamentally our problem. So essentially, what's got to happen is somebody's got to tell the plant to start doing. And that comes typically from a chain of events. A forecast leads to a production plan. You forecast what you're going to do. you develop a production plan to implement the forecast, and then you create a master schedule. Once you hit the master schedule level, you're in the plant. And you're actually telling people, you're about to tell people to do things. People do stuff, the stuff moves, right? And they give feedback. How do we know you're done? Right? Now, if your background includes accounting, as we do feedback, we're also collecting management accounting type information about the costs we've expended to date. So with my example of baking cookies, right, if you could picture what happens, it's going to go something like this. You go to the supermarket, you buy a bunch of stuff, and you now have $100 worth of inventory, correct? Or whatever you bought, right? If you have several teenagers at home, it might be $400. They eat more, right? Okay, any event. When you go to make the cookies, you now take things out of inventory and apply them to making the cookies. That increases what's called your work in process inventory, because now you have materials and labor committed to making cookies. And the same thing's going to happen in the plant. What will happen is your order for the cookies will start to accumulate cost. Now, somewhere along the way, you'll apply labor. Like, you'll throw everything, all the dry ingredients in a bowl, and you'll sort of sift them up, right? That's a process operation that required what? A tool. That also costs money, and now gets expended. Now, granted, I'm having some fun with this, but the concept is perfect, right? Think about it. You go to make cookies, now you use the various cooking implements as part of making the cookies, right? Next, somewhere along the way, I'm applying energy to the problem, right? Because I had to preheat the oven. I'm now collecting what? I'm applying the cost of energy to the cost of the cookies. Make sense? When I'm done, the cookies do what? They sit around and cool off. They do nothing, but they use up space on the counter, don't they? Then they get put in a cookie jar, which in our class we would call finished goods inventory, where someone unauthorized will grab them and eat them, right? And then you'll have a stock out. Okay, so any event, it is fun to describe it that way, but it makes, in a sense, helps people. Because if I talk to you about making something like an aircraft, most people who take this class have no idea what that looks like, right? Whereas most people who take this class have seen someone bake cookies or something like that, right? Typically what used to happen is you'd issue a shop order for some quantity of goods. And this could be an economic order quantity, or it could be a process-determined quantity, like the pizza problem. You can only make 100 at a time, whether you liked it or not. Now, that happens a lot in industrial settings. For example, people will make a die set, and the thing will make 8 parts at a time, or 12 parts at a time. And the reason they do that is making one makes no sense. If you're going to heat up everything, you might as well make a few. And then the size of the machine tells you something. Now, even with our friend, the 3D prototypers, you got problems with size of machine. Because those maker bots that everyone says you can have one at your house, that's great as long as you only want to make something about maybe what, 4 by 4 by 4? A little bigger? Not making much of a part that way, right? Okay, so we issue a shop order for some quantity of goods. We make a kit, or we deliver materials to the workstation. That creates our work in process. We do the thing, and then we move the material to the next step. So say, for example, when I worked in electronics manufacturing, there would be a kit assembled in a stock room that would include enough parts to make, say, 1 printed wire board, or 10 printed wire boards, whatever. And the 1 or the 10 would be dependent on a whole bunch of things. The problem with this method is pushes things through the process. This is what's called a push system. What we really want to think about is what's called a pull system. See, in many of these type settings, people would make extras because it didn't make sense to make one for a variety of reasons. What we would like to have happen is we only build what we need. We build it when we need it. Always do it right. Build with minimum resource use. When you hear the term lean, or just in time, that's really what people are thinking about. So think of it this way. if we were making a trip over to a fast food restaurant, they could generate 50 burgers at a time and sell finished goods inventory, pre-assembled. Or they could do what? Do the Wendy's model, right? The Wendy's model would be they try to deliver what you want when you want it. How's that work? Not as efficient as just give me one of those. Therein lies the tension of doing these things. Now, a few weeks ago, we had a little discussion where I was pointing out one of the idiosyncrasies of Starbucks, which was the people getting those drinks with the whipped cream and 3 shots of syrup and all that. That's a just-in-time model, isn't it? What does that do for all the other people online? You definitely get the drink made the way you want it. What they might need is more people back there. But then, depending on the Starbucks, there might not be room for more people, and so forth. Regular black coffee is made not 1 cup at a time, but a pot at a time, right? And what happens to the pot after a certain amount of time at those places? In theory, it gets tossed, which is what? A shelf life issue, right? You lose inventory because people didn't buy it. We can adopt these systems to different types of things. And how we do that is we actually apply some of those undergrad classes. How did things go through the shop? What's the flow of the process? How do you design the work? What are the methods you use? And in real manufacturing, you have tools, dies, fixtures, jigs, all that stuff, right? And you also have a topic hated by many people, work measurement. How much labor goes into something? Because the standards help generate our expected labor cost. Because what's of interest to us is what does our product sell for and what do we make it for. If it costs $10 to make it and we can sell it for $7, better hope you have an understanding grandma as an investor, right? Because she's not going to get her money back anytime soon, correct? Alternatively, if you think it will sell, has $10 of labor in it, and you can get $5 of labor out, that's great, right? You can get a promotion. Of course, $5 worth of people are no longer part of the show, but that's a story for a different class. So essentially, as we think about doing things, right? Even if you think about baking cookies, can you bake cookies, for example, in a toaster oven? They cost $30. You plug them in. Sure. How many can you bake? Maybe 8? If you need like 6 dozen cookies, you need a real oven, right? Real ovens cost more. Just an example. If you're the people who bake Girl Scout cookies this time of year, your process is probably doing nothing. It's working on something else. Because Girl Scout cookies have been being sold for some time now. Or so I learned from Twitter. And I've seen them out selling, but usually around the college there's a parent Girl Scout. So wait a minute, where's your uniform, right? They always forget their sash. So, any event, all of this is stuff people are doing for real, because as you do this, right, what happens? You're affecting how the product's made. You're affecting potentially the process quality and the ability of the thing to produce on time. Because what people are going to do is take the standards that some IEs generate and try to forecast how many people are needed to do things, how many machines. Do we have enough workers? Do we have enough? And if you've overestimated that, you're going to hire a whole bunch of people, many of whom are not going to be doing anything. So, our focus: use the resources wisely, right? Eliminate waste. Waste is bad. Generally, as I say, let's do this one time correctly instead of 28 times wrong. And usually somewhere in that discussion, some grad assistant says, "Good luck with that, Dr. Pines," and I usually laugh. What's key is when you do something, it should add value. What's the customer value of this thing? Imagine the following scenario. Okay, you're in the cookie baking business. You box up the cookies and you hire a group of people to tie pink ribbons to the boxes. All right? Or yellow ribbons or green ribbons. It doesn't matter. All right? Everyone with me so far? There should be a reason for that, other than you think it looks good. Like somebody should say what? I'm going to buy cookies because they have a pink or yellow ribbon. Besides the aesthetic joy of the ribbon, what you need is a customer who will pay for that part of the process. I mean, I know that sounds sort of absurd, but I'm just picking on something. Realistically, extra finishing is, as Dr. Valles would tell you in her Six Sigma class, not needed. Therefore, don't do it. So if the pink ribbons and the yellow ribbons and the green ribbons are no big deal to the customer, why do it? Doesn't add value. Alternatively, if the customer likes ribbons, by all means, because they're willing to pay for it. What we're hoping to calculate from all this is how many people do we need? How much inventory do we need? How much money we need? And be able to figure out, can we serve the customer? How many people? Of what types? How much stuff should we have around? So when we think about this, what you got to be thinking about is whatever you make, you got to have enough of it to deliver, right? And it has to be deliverable when the customer wants it, not when you want to give it to them. Minor detail, right? To do that, you need people working and inventory, which means you need ding ding money. You turn money into inventory and workers who do stuff that produces customer service. It's a great system. Not too long ago, during the start of the semester, we ran into a couple of capacity issues on classes, and some of the people in the 424 were scheduled to take ie480 but couldn't take it till the summer or fall, right? So of course, what do I get out of that? I get a lot of people pointing out if I hired enough faculty, I wouldn't have this problem. And I said, excellent, good idea. I'm glad you shared that with me. I couldn't have thought of that on my own. And the person said, why are you picking on me? And I said, because it might have occurred to you, if I could hire another person to teach it, I might have done that. What's the problem? I don't have enough money to hire another person. Plus, I have a capacity issue on campus at the moment. Can't find a big enough classroom or enough classrooms. I said, see, this is why you should think through what's in your textbook before you open and provide feedback. And the point of telling you this is when you think that people should be doing something, one of the things you should look at is what's their cash flow situation. Now, of course, if you're an undergrad in IE, the chance that I'm going to actually deliver the cash flow situation is 0. But one reasonable assumption might be that it probably isn't there if it isn't happening. And in a real setting, you could actually explore that with the person. Say if you were a consulting person, say, where does your cash flow come from? Do you have enough working capital to hire workers and that kind of thing. In fact, this came up with summer school. There was a discussion of if we could generate enough funds through registration, could there be more summer classes? And when I looked at somebody's draft proposal, and I pointed out maybe they don't have the front-end cash to load this thing. Which, of course, everyone said, well, you know, you're going to make a lot of money. And I said, well, yeah. In theory, you would, but first you got to have the wherewithal to actually hire the workers, right? So all of this ties to money. And so everything I talk about is trying to reduce the amount of money we're expending to get a result. And it isn't because I'm like some cheap guy that only wants people to do it out. It's that if you want to do the job right, you got to spend what's indicated. So for now, just assume everything can easily happen. Nice assumption, right? Tonight, you go home, there'll be a call from a major league scout. That kind of easy. There's two methods of doing things that are used in industry. Historically, we forecasted demand. As a result, we ordered material. We put it through a number of stages, and we put the product in inventory. Now, this works great if you have make to order. I need 50 aircraft. The forecast is a fixed contract. That's beautiful. All you got to worry about is the raw material is correct and all the process steps do what they do. When I present some of these homework problems, right? The demand's all forecasted. You're assuming the forecast works, right? Do they work? Well, by definition, all forecasts are wrong. Some are wronger than others. But if you forecast low, you don't have enough stuff when you're done. If you forecast high, you have too much stuff, you have to have a sale. Now, what came about over time is the idea of a pull system, which is the customer signals you to do more by buying a product. See, here the signal is the forecast, right? Here the signal is the customer does something. Means inventory is depleted, which means you could eventually order more material. And again, this is very high level. But fundamentally, if I push material out, what I'm doing is dumping a bunch of material in the plant and expecting people to work their way through it. This way, what authorizes a build is somebody buying something. If they buy it, then we'll make more. Now, it's not quite that simple typically, but it's the starting point. To do pull manufacturing, typically people talk about just-in-time production. And the simplest level is, of course, one product with a constant demand rate. All the resources are there, everything works, right? Now, if I were teaching an industrial seminar, there would be at least one person who would be leaping out of their seat at this point, trying to point out what an idiot I am, how none of this makes any sense in the real world. And the answer to that is, of course, that's true. But you got to start with restrictive assumptions and then relax assumptions. It's not good to model the most complex situation first. You never get to the end. Because certainly no one who's listened to me for very long believes I think the material's always perfect, for one thing. And from then on, we have other things that could occur. So the processing time per unit would be N steps, T time units. Which means we get N stations, constant processing time, all of this. Everyone always shows up for work. Also, not exactly correct. If I'm trying to do something just in time, what I'm really trying to do is generate a process that can work on one item and produce it in such a way that as the customer takes one, you can make another one. Alternatively, you could forecast this year we'll sell 1 million widgets, right? Come up with whatever seasonal adjustments you like. Start building widgets to stock. Even if you got an order, start building them to the order. Push all the stuff out into the factory. The problem with that, when you push, you're committing money early. You're going to just keep committing money in hopes that someday someone will buy the thing. If you think about it like a cash flow diagram, there's a whole lot of negatives in hopes that someday down here somebody buys the thing, right? The fewer the things we make at a time, less dollars I spend, right? So really what goes on, regardless of what you read in Harvard Business Review or IE magazine, ISE magazine now, whatever you read is fundamentally you're trying to do what? Serve the customer efficiently, but you got to have the stuff there to sell them. So if you have a process that's highly efficient, you could have two versions of it. You could have one that's efficient at making lots of stuff, or you could have one that's efficient at making one at a time and keep plopping one out every time somebody grabs one. It's not quite that efficient, but conceptually. Ideally, what would happen? If you head down to the mini mart and grab a 6-pack of Diet Coke, in theory another one appears. That's probably a little unrealistic, right? But the closer the people get to that, the less inventory they're committing. What typically happens in the real world setting is people try to get economies of scale when they do things. So what do? They buy more raw material. Example, if you need one 12-foot bar, it might cost more to get it shipped to you than the bar costs. So what are you going to do? Try to get more, which means now you've spent more money. Generally, in the past, what people have done is increase their inventory and overproduce. You need 10, you make 12. Lost production, defective materials, that kind of thing, right? If we go back to the thing on cookies, if you want a cookie, the idea of making one is a little shaky, right? I mean, in theory, you could do it. The setup and production costs would be unbelievable, right? So usually you make them by the batch, correct? Now, if you watch some old TV shows, you'll encounter some character who makes large batches so that no one goes hungry, right? What is this person doing? They're overproducing, right? Creating more food. What do they want to do? Get rid of the extra, so you get a take-home package, right? Yeah, I'm ruining everything today, aren't I? Think about it, though. Like, you got some stereotype character on television making dinner. They don't make exactly 4 portions for 4 people, right? In fact, in many cultural settings, that would be viewed as unduly cheap, perhaps badly representative of things, right? Obviously, our protagonist didn't do what? Pay attention to this story, right? What's the other problem? The protagonist is worried about reputation, which brings to mind what? They're accounting for uncertainty, aren't they? Plus, they want to make sure they're not thought of as unduly cheap, right? They don't care about their inventory costs, do they? They do, however, care if there's like 1 portion left. And then we can have a funny vignette about who's going to eat the last piece of cake, right? Or the last piece of lasagna or something like that, correct? But what are they doing? They don't want to store it either. Minor detail, right? Let's get rid of it rather than keep it around. How do they get rid of it? We make a funny story about who gets to eat the last piece of cake. In a real plant, however, people run into raw material problems, they run into processing problems, so they overmake. Usually, people don't like to pay setup costs, so they tend to like to amortize setup costs over larger production runs. So now we have more stuff around. What does this argue for? Reducing setup times. In fact, back in the day when cars were made out of metal, minor detail, right? 57 Chevys and that sort of thing. What would often happen is the plant would close for 2 weeks, the workers go on vacation, and suddenly all the new die sets and things were put in. And then they'd bang out. The plant was out of business for 2 weeks. That's pretty expensive, right? So you got to make a lot. And our friend Shigeo Shingo, after some amount of study of that at Toyota, came up with the idea of single-minute exchange of dies in an attempt to reduce setup costs to make it easier to make small quantities of car parts. And typically what people did in the past was have these large interstage inventories, they call them. You make a lot so that the guy downstream doesn't run out of parts. Because you would not want the downstream people to be worried about where things are coming from. And in fact, in the early days of just-in-time, one of the big problems for the philosophers was that people in plants are really sensitive to what's coming into the plant. they're fully aware of what the backlog of orders is. And so they had to work with people in the shop and change their cultural perspective, because they used to look for large early stage orders, which meant there would be more work downstream. And culturally, when people are used to that, if you say, no, we're going to cut those orders, what does that mean? That doesn't mean something good. So historically, as people tried to go from pushing out large volumes of things to pulling smaller volumes, they ran into problems explaining to people what was happening. And many gallons of ink and electrons were wasted on articles and presentations about this, the need for education and training, and so forth. This one is a big deal. This one's a big deal. How you fix delivery variance is you develop relationships with suppliers, and you share your schedule. You can even fix delivery variance and economies of scale at the same time by saying, hey, here's a contract for a year, give me 50 every week. That sort of thing. Here, if you improve the quality of your process, you don't have to overproduce for defective stuff. Here, as your setup costs go down, you should have learned from doing those calculations, right? The cost of keeping the thing around goes down, right? So if it costs you, say, $600 to set up a machine, for argument's sake, and the first part uses up $1 worth of machine time, the first part cost $601, didn't it? The second part costs virtually nothing. Start to amortize that $600. So the more we can reduce setup costs by having more efficient setups, the faster we can produce less. So in the early 1980s, when people started evolving into just-in-time pull scheduling, it was a rough adjustment for a lot of people. You need some assured demand. You go with smaller lot sizes, as low as 1, potentially. My ability to respond quickly is my substitute. What this suggests is vendors who are nearby physically, collaborative work with the vendors, not just the usual competitive kinds of things. An emphasis on product and process quality is what that says. When people start remembering some of the glory days of manufacturing in these political diatribes, one of the things they leave out is that in the good old days, people were making a lot of stuff, and often it wasn't all that good. Because if you do a little search of recent industrial history, you'll find out that in the 1980s, there was quite a renaissance in manufacturing. Because suddenly manufacturing that was cars that were built in the U.S. were not so good compared to the cars you could buy from Toyota and Nissan and Honda and so forth. Now things have changed over time, but the cars that were made, say, like in the 1950s and 60s weren't that great. In fact, in one of my other classes I mentioned, there used to be the concept of blueprinting engines amongst people that wanted their cars to go fast, where they would take the engine apart and remake all the parts to the exact specs. And part of the reason for that is, as you know, if you're an ME, it's sort of hard to get the engine to work right if the piston isn't where it's supposed to be, right? And so forth. So when you think about it, the only way you can make this work is to make this work. You got to be able to make stuff on time that will always be solid. You got to be able to work with your vendors, and in the past, vendors were almost viewed as competition. When I was in the junior engineering business, I was forced to get multiple quotes from multiple people. And I always thought it odd that we were putting people at odds with each other to get the business, and that was to do what? Get the cheapest price. And then, of course, out of that came what? Maybe not the best product, but the cheapest one, which is good, as all you worry about is money. But in the long run, it's harder to measure it, but quality products are going to be cheaper in the long run because you won't have to fix them. If you take quality control, like do the cost model, not a problem. So, any event, we are kind of out of time, but think about the idea, how do we get stuff? Like whatever it is, we need some kind of signal to kick it all in gear. And then as we kick it into gear, there's got to be a way to get everything done sequentially. See you next time. Have a good day, everyone.